Hello everyone. In this video, we'll see how we can trace a RAG-based application within LangSmith. This will probably be the last demo for a while under observability. We'll then move on to evals and prompt engineering. But before moving on to the demo, let's try and understand what a RAG-based application is. So traditionally, an LLM takes in an input and gives you the output, right? But one of the drawbacks is that at the core, LLMs have been trained only up to a certain cutoff. So they don't have access to any of the latest information, nor do they have access to your personal data. So when you ask it a query or ask it a question, it's going to hallucinate and not give you any accurate responses. So to sort of tackle this problem, we have something called the RAG workflow or retrieval augmented generation. So you start with a bunch of documents. These are, let's say, in up to current documents of something, or it could be your company specific files, documents, and so on, right? So you start with a bunch of documents and then you chunk it into smaller bits. So these can be smaller phrases, sentences, words, and so on. So once you chunk them, these are then converted to a vector store. So basically, you're embedding them to and storing it inside a vector store. And this, in essence, forms the knowledge base for the LLM. So you're starting from a bunch of documents, PDFs, CSVs, databases, and so on, and converting into smaller embedded vectors. So now, when the user passes their query, a copy of it is sent to the vector store, right? And relevant pieces of documents are retrieved. By relevant, I mean the pieces of information from the document that are relevant to this query. So the document is going to have loads and loads of information, which are obviously chunked and stored in the vector store. But for this query, we are going to retrieve only those set of documents that are relevant, right? So it's going to do a similarity search and pick only those pieces of information. So this process is called as the retrieval. Now, along with the original query, these retrieved documents are passed on to the LLM, and this step is called the augmentation, right? So earlier we passed only the query. Now we are passing the query along with some relevant pieces of information. So now the LLM finally generates the answer that is relevant to the query with the help of the knowledge base that we created. So we're doing a retrieval, augmentation, and then generation, which forms the RAG or the basis of RAG. Now for this demo, let's say I'm building a chatbot for a cafe, right? Users can come onto the platform and ask questions to the chatbot about the cafe. So I have this knowledge base here, or let's say the master document here. It's a two-page PDF, has details about the opening hours, location, contact, food details, allergies, pricing, and so on. So if you go here, this is the document that we are starting with, right? Now what I've already done is I've chunked it into smaller pieces and I've created a vector store. So I have the knowledge base ready. We're just going to see when we query it, how the retrieval, augmentation, and the generation step takes place. So let's go back to LangSmith. This is the code. We just need to pass in the information. This is based out of LangGraph. Let's say, hey, what time does the store open on weekends? If you go to this PDF, you can see that we don't have a specific sort of information for weekends, but we have Saturdays and Sundays mentioned, right? So it should be able to, or it should try and find out this and give us the answer. So if you see, the store opens 8 a.m. on Saturday and 9 a.m. on Sunday. So that's accurate, right? Now let's go to LangSmith and see how uh, this has been traced. So we have our project here. This is the latest trace. So like I mentioned, this bunch of steps have already been done. For this workflow, we are just looking at RAG, retrieval, augmentation, and the generation bits. So if you see here, we have the two portions here. Um, at the retrieval stage, it takes in the input and it picks up relevant documents from the knowledge base. So if I open this for comparison, so it's a picked one sort of chunk that says the Saturday and the Sunday timings, one information from this Monday to Friday, and a couple of others. It's not relevant, but I think it's picking the last four, so top four. So it to to some extent it has found some similarity with the questions and the chunk pieces, right? So this is the retrieved documents. At the generation step, it also does augmentation within here. So this is the like the chat prompt that as a user I provided. It has the context here. Context is the retrieved pieces of information, and then the question. So at the retrieval step, we had only the question. At the generation step, it has the question and also the relevant context. So when this entire thing is passed on to the LLM, it is now able to um, answer the query of the user accurately and more specifically to what the store has to offer. Let's maybe try and question some more. Let's go back here and let's say what can I get for or get under 5 pounds. So it says you can get vegan wraps and so on. um, if we go here, so it has picked up what, three, four, five dishes. I think it has picked up all of this, but it has skipped the drinks, right? Let's go and see what's happening in LangSmith. Um, so this is the latest trace. We have the retrieval. What can I get under 5 pounds? So it has picked up the food. So it has picked up the food details, right? It has sort of skipped the beverages and the coffee pieces of information. And at the retrieval generation step, it's based on this information, right? So it just does not have the context of the others. Now, obviously, this is a simple app, so it may not be doing an efficient retrieval. We need to go back to this sort of chunking and maybe try and optimize this step. Or there are different retrieval steps as well. Those are again within a RAG-based optimization. Um, but what LangSmith does is it lets you see the kind of retrieval that's been done or the kind of context that's been passed on here. So now you will know what's going wrong and you can go back and obviously try and fix this. And this is where LangSmith stands out, right? Let's now just go back and do one final example that's not relevant to this piece of information, right? Let's say uh, what's the price of a pizza? Now, of course, this is a coffee shop, so it should not have relevant information. One thing that I've passed on the prompt is that if the context does not contain enough information, please say you don't know the answer. So this is sort of a guardrail that I've provided within the prompt, and that should be followed, right? I'm sorry, I don't have enough information to answer the question. If we go back to LangSmith, let's see if it is retrieving any documents in the first place. It is picking up. Ideally, it should not. But of course, this is a simple retrieval, so it's doing some sort of keyword matching and finding documents. But of course, when we come to the generation, none of this piece of information is relevant to a pizza, right? So, which is why it says it does not have enough information, because it then falls back to the guardrail that we provided. We'll do one more example actually. Let's try and combine a complex question and see what kind of documents it's picking. Let's say where's the store located? Um, can I come at 10 p.m.? Give me a contact number if possible, right? So I've asked it three different questions. Store located, we have the information. 10 p.m. ideally no, because it closes by 9, and contact details should be one of these two, right? So the store is located at this. You cannot visit at 10 p.m. as the store closes at 8 p.m. from Monday to Friday and 9 p.m. on Saturday and 6 p.m. on Sunday. That's very good, right? So it's able to pick up all the information here. And I'm sorry, the context does not provide a contact number. Okay, so this is bad. It obviously has a contact number. I guess if I had asked it to just give me a contact number, it would have been able to do so. And I'll tell you why it wasn't able to pick up the information last time. Um, yeah, so see, the contact number is this, right? Let's go back to LangSmith. So we'll see the earlier trace first. At the retrieval step, it's picked the opening times, it's picked the location, and it's picked some payment details. So the thing is, by default, it's picking up the top four relevant pieces of information, right? So it has skipped the contact bits. So out of the retrieved contacts, retrieved pieces of information, it has no details of the contact, right? So it's able to tell us the sort of closing times, it's able to tell us the location, but it does not have the contact. It did pick up the contact piece of information, but I think during the chunking, the other bit just went off to a different subtext, right? Document. So it did not have enough information while generating the answer, but nonetheless, I think it was able to pick up a lot of context which would not have made sense otherwise. But because we have provided it enough context, it's what they're able to do so. So these are the things you can track within LangSmith, right? You can see how the work is, the sort of data is flowing. So you can obviously go back and improvise your workflow. Yeah, this should have worked because this was a straightforward answer. Yeah, it picked up these details. So this is the demo of how we could trace a RAG workflow within LangSmith. Thanks for watching until now. I think next video we'll try and start with evals, build some data sets and experimentations within there. And I'll see you in the next video then. Thank you.